Okay. So we started off Unit 2 by talking about a tool that geometry uses called logic and reasoning to prove things are true. And then we're going to actually start getting into the way that they use those things, which is called proofs. We're going to start by doing it with something familiar, which is algebra, something you guys have seen before. And then through the next few lessons, we'll be gradually weeding you guys into what a geometry proof looks like. So this is kind of how geometry people will show their work, if you will. Okay. So what we have here is we've got a list of a few algebraic properties. If A is equal to B, if you add the same thing on both sides of the equation, it stays equal. We call that the addition property of equality. So, for instance, 5 equals 5, right? Well, if I add the same thing on both sides, it stays equal, right? That's called the addition property. The same thing applies for subtraction. If you subtract the same thing on both sides, we call that the subtraction property of equality. If you multiply both sides by the same thing, we call that the multiplication property. And if you divide both sides by the same thing, we call that the division property. Substitution property, we probably won't be using that today. We'll get into that in one of our future lessons here. But we used it actually when we were doing, actually no, I'm thinking of my algebra class, never mind. But if two things are equal, you can replace one thing with the other because they're equal, right? And then we also have here the distribution property. That's where if you have these parentheses, right, you can multiply this thing to the inside and get a new expression out of it. So these are some basic algebra properties. We've got some other ones down here that we're going to talk about later, but for now we'll stop here at the distributive property. I handed out to you guys some notes. Go ahead and flip those notes over. We're going to do something on the back here now. Go ahead and copy down example 1, and I'll show you how we'll kind of get used to these things that are called proofs in geometry. All right, so they give us this equation up here on the top, and they're asking us to prove that x is equal to negative 15 over 2. So this is not going to be unfamiliar to you guys. You've seen this. It's just that I'm setting it up a little bit differently. So let's start by writing this out. And yes, write it again. That's part of what we call a proof, is you start by writing what's given. Okay. Now, if I asked you guys what's the first thing to do with this, what would you say? No substitution. No like terms. It's we would start with this parenthesis thing here. We're going to distribute. And so if I distributed, that's going to give me 2x minus 6. Okay? The other side's going to stay the same. Now, for a proof, what we do is we're going to give a reason for each of these steps. Okay? We have to justify every step with a math rule. Okay? It's kind of like that, you know, it's like whenever somebody tells you a fact, you're like, well, where did you get that information? So, in this case, where did this first statement come from here that I wrote down? Well, that was given to us. So let's go ahead and write the word given here. How did we get from here to here? Well, we used the distribution property of equality. You guys are like, well, where the heck is he getting those words from? It's on the other side of your paper. If you want to look at it, it's part B. It's the distribution property of equality. We're allowed to do that. That's a math rule. That's our evidence that we're allowed to do that. So after every step, we're gonna state a particular rule that we used to come to that conclusion. So, anybody want to take a guess at what the next step would be? Mm-hmm. Kind of. I'm not going to call it combined like terms, but what like terms did you have in mind? So the 4x and the 2x, right? So thank you, I'll get you some extra points for that. So what we notice is we don't like having x's on both sides, right? So we want to get rid of an x on one of the sides, and I've always suggested you get rid of the smaller one. So let's go ahead and we'll subtract 2x on both sides. So now this goes away, and I'm just left with negative 6 equals 4 take away 2 is 2x, and then plus 9. Okay? Now, look at the other side of your notes. What do we call it whenever you subtract the same thing on both sides of an equation? What's it called when you subtract both sides on the side? Both things, the same thing on both sides of the equation. What is it? Let's take a look. So if you have two things that are equal and you subtract the same thing on both sides, that's called the subtraction property of equality. It's pretty nice because the name pretty much matches exactly what you do, right? So that's kind of makes it nice. So to get from, let's put a 1 here, let's put a 2 here. To get from this second step to get to this third step, we subtracted the same thing on both sides. And my reason for that is the subtraction property of equality. I wouldn't put like up here I shortened this with the distribution with the word dist. I wouldn't shorten that with the word sub because there's two properties. There's substitution property we talked about also. So we want to be a little bit clear about what we're saying when we do those abbreviations. All right, so the first thing came from given. It was given to us. The second thing came from distribution property of equality. The third thing came from subtraction property. All right, what would I do now to solve? No, we wouldn't divide the negative 6. I'm trying to get x by itself. I would subtract 9 on both sides because we're trying to get x by itself. So let's go ahead and subtract 9 on both sides. This becomes negative 15. And we'll bring down the 2x, and the 9's are gone now, right? So what property do you think I'm going to put over here for that? What did I do? It's subtraction again. We did subtraction property of equality again. Okay, let's do the fifth step. So now I want to get x by itself, so what do I do now? Divide by 2, right? So if I divide both sides by 2, I get negative 15 over 2 equals x. And what property do you think I'm going to put over here? That's the division property of equality, yeah. If you have an equation, you could just divide the same thing on both sides, and that's a legal move. So in geometry, every time we make a step, we cite evidence to prove that that step was a legal move to make. Now this is algebra. We typically don't do it with algebra, but I'm starting with something familiar. You'll see why this is a little bit more necessary when we get to geometry. Now, you can leave these on your paper if you want to, but these things here, like where I subtracted 2x on both sides, that was just me showing my work. Really, in a proof, you don't show the steps, you just put the results. So to get from here to here, I distributed. To get from here to here, we subtracted. And then to get from step 3 to step 4, I subtracted. So you just put the result of each step there. I don't mind if you leave that work on your paper, but just know that like on a quiz or a test, they're not going to show the work. They're just going to show you the results. And you'll have to supply like the reasons or something like that. Okay? So we started with given, then we distributed, then we subtracted twice, and then we divided. And all of those are justified steps because we're using real math properties. All right, let's go ahead and do a guided practice here. And by the way, let's go back and add something here, guys. Can you add a line here and here? We call this the statements. These are the things that we're stating are true. So these are called the statements. Over here, these are what we call the reasons. have statements on the left, reasons on the right. Okay. Let's go ahead and do our first guided practice here. Go ahead and copy that down, please. All right, so we're going to start off with our little T-chart here, right? We're going to do statement on this side. We're going to put reasons on this side. Okay. Now, we always start off with the same thing. So, Jaden, what do you think I'm going to put first here? The given information, yeah. My given information is that 4x plus 8 is equal to 12x minus 16. I'm trying to prove that x equals 3. And my reason for that is, as Jaden already said, given. That's what's given to us. All right, let's do step 2 here. All right, so think for a moment about what you think the next step might be, and I'll call on you and ask, what do you think we might do next? So Joe, what do you think we might do next to solve this equation? Say that again?
I'm not done writing it down.
Okay. Jonathan Saparov, what would you say is the next step? Yep. So I'll do that in red. This is something that technically you wouldn't see in the table. You don't show the work, but you just put the result. But I'm gonna write it just because we're getting used to this. So minus 4x on both sides like that. Now if I do that, we're gonna put the result here. So right here, the 4x's are gonna go away, and we'll have 8 here. 12 take away 4 leaves me with 8 here, and we still have that 16. All right, Jonathan Sanchez, what property is that the other Jonathan did for us? Yeah, we're going to put the subtraction. I think if you can abbreviate that SUBT, subtraction, property of equality, and we can cheat there and just put POE, property of equality, POE. All right, let's go ahead and move on to our third step here. Joseph, what would you say is the next step to solve this equation? Yeah, we want to add 16. Now, once again, I wouldn't necessarily show this plus 16 in my table. I don't care if you do, but just don't be surprised on like a test. They won't have that red stuff there. They'll just have the results. So 8 plus 16 is 24. Then we bring down our 8x, and the 16s are gone. And so, let me ask Joshua, what property did Joseph use there? Yeah, we haven't done that one yet today, but the addition property of equality. If you have two things that are equal and you add the same thing on both sides, it stays equal. That's a good property to use to start getting x by itself. All right, so Milani, what would you say we do next to solve for x here? We would divide, and once again, I'm going to do it in red. You wouldn't see this on the actual proof table, but I'm going to write it just because we're getting used to it. All right, so the result, though, would be 24 divided by 8, which is 3, and 8 divided by 8, which is 1, so we have 1x. Now, I've proven that x equals 3, right? That's what I was trying to prove, is that x equals 3. We got there. All right, so step 4, we need to put the reason for it, though. Malia, what reason do you think we'll put there for that? Yeah, that's the division property of equality. Okay, if you guys were to see this proof actually written out, they wouldn't have the red stuff there. This is what it would look like. The red stuff is just you kind of like showing your work as you go. In geometry, though, there's no work to show. We just have statements, and then our work is the reasons we're giving. But there is work to show in algebra, so you can. All right, so here's a student practice for you guys. I'd like you to give that a try, and then we'll see how you guys did with that. Just make your corrections as we go. So we're going to have our statement column here, right? And we're going to have our reason column over here. All right. So let's start off with Melina. Melina, what's my first statement going to be? Great, thank you. That's my first statement. And Melina, what's my first reason going to be? That's the second reason. So I'll give you a point for that. But your first reason is always going to be given. All right, so we'll get to that second reason. So Melina's pointing out that the first reason after that is going to be the distribution property of equality. Now, how would you know that it's the distribution? Well, you got to remember your algebra for that. So if you're if you don't remember how to solve equations really well, this would be kind of tricky for you. But if you remember how to solve, you should know. Oh, we start with distribution, right? But if not, we just got to keep practicing it. Let's go to Misty. So Misty, we are going to distribute. So if I distribute, what would my second statement be? Good. I'm just going to put minus 10, but if you put plus a negative 10, that's totally cool. All right, Nehemiah, what will my third statement be? Yeah, just 2x, right? That's going to be your third statement. Now, how did we get there? So let's ask Neve. Neve, how do we get from statement 2 to 3? What did we do? Yep, we added 10 on both sides. So that would be the addition property of equality. You notice I'm not showing the work this time. Once again, I don't care if you show the work, but this is what it would really look like. Nick, what would the fourth statement be?
Negative 12 equals x.
There it is. All right, and that would be, Roxana, what's the reason for that one? I'm not sure. Hey, go ahead, Isaac. What do you think? It would be our division property, because to get from number 3 to number 4, you would have to divide both sides by negative 2. Now, I'm going to add a new property for you guys, okay? They wanted me to prove that x is equal to negative 12. We've done it. I think this is kind of silly, especially for algebra, but it doesn't look the same, does it? But let me ask you guys this. If these two pins weigh the same amount, right, and I switch them, do they still weigh the same? Okay, right? So it doesn't, with an equation, it doesn't matter what side they're on, right? So we can actually switch these around, and there's actually a property for that, believe it or not. I believe it's called the symmetric property of equality, and I'm going to show it to you on the next, when we move on, because remember I said there's a few extra properties I'll share with you. That's one of them. You can flip it around. Honestly, if you didn't do that, I don't even care. Not with an algebra problem. There's times in geometry where you kind of need to be able to do something like that. With algebra, I would always accept negative 12 equals x just as much as I would accept x equals negative 12. It's just geometry sometimes a little bit different. So there's that. All right, that's what we call a proof. You have your statements and you have your reasons. This is how geometry shows its work. It makes claims on the left, and it uses rules, math rules, to prove that those steps are okay. And how do you get from step 1 to 5? Well, For this, you guys just remembered all your algebra rules. But in geometry, the way that you get from step 1 to step 2 is by reasoning, by logic. Well, if this is true, then this is true. We'll get to that, though. We're not ready for geometry proofs just yet, but we'll get there. All right, so let's come back to the front of our notes. I left off a few properties that we'll talk about now. Here we go. We have these 3 properties. All right? We have the reflexive property. The reflexive property says something is equal to itself. Now you might think that's like absurd. Like, really? They made a rule to prove that something is equal to itself? They did. There's a reason for it in geometry, though. So just for now, hold on to it. But for now, it looks silly. But yes, there's a property that says anything is equal to itself. Like 2 is equal to 2, or segment AB is equal in length to segment AB. Anything is equal to itself. That's called the reflexive property. I just showed you guys this one on the last problem, the symmetric property. If A is equal to B, then B is equal to A. The order doesn't matter, right? That's called the symmetric property. This one's a little bit harder to follow, so let me see if I can explain it to you guys a little bit. John weighs as much as Nehemiah, right? Nehemiah weighs as much as Joseph. Okay, so John weighs just as much as Nehemiah. Nehemiah weighs just as much as Joseph. What can you guys tell me about John and Joseph? They weigh the same, right? They're all the same. So this property looks a lot like something we've already made. John weighs as much as Joseph. So here's now let me write this out in math style, okay? Be nice if buttons would work. It would be so amazing, but not today. Not today. All right, so we'll do this instead. So John weighs as much as Nehemiah. Nehemiah weighs as much as Joseph. I'll put some extra letters here. So John weighs as much as Nehemiah. Nehemiah weighs as much as Joseph. So John weighs as much as Joseph. What property does that remind us of? Anybody want to remember what that property? I know what it is on here, but we've learned something a lot like this before. It looked like this. Oh yeah? That's a syllogism, isn't it? If J, then N. If N, then J. Then therefore, if J, then J. You connect the first and last one. That's a syllogism, right? But this is not an if-then thing. A syllogism applies to if-then. This has to do with equality. And when it comes to equality, we call it a transitive property of equality. If A is equal to B and B is equal to C, then we can say that the first one is also equal to the last one. A is equal to C. That's the transitive property. So what we're going to do here is we're going to identify what these properties are. So let's take a look at the first one. If the measure of angle 6 is equal to the measure of angle 7, then the measure of angle 7 is equal to 6. Well, it looks like they just switched them, right? That's called, look at your properties, that's the symmetric property of equality. When you just switch them, 6 equals 7 and 7 equals 6 for the angles, well, that's the symmetric property. Let's take a look at another one. We have 34 is equal to itself. That's which one? That's the reflexive property of equality. All right, let's look at this last one here. 1 is equal to 2. 2 is equal to 5. So 1 is equal to 5. That's the transitive property of equality. Okay, I'd like you guys to label these three for me. Tell me what properties those ones are, and I'll ask you guys what you got in just a second here. William, what did you put for the first one? What property did you think that was? It is the transitive property. If JK is equal to KL and KL is equal to 16, since they're connected in the middle here, then that means the first and the last one also have to be connected. So JK is equal to 16. That's the transitive property. Let's go ahead and take a look at the next one. Aaron, what did you think about this next one? If PQ is equal to ST, then ST is equal to PQ. Yeah. When you just reverse the order, it's called the symmetric property of equality. All right, and then Aram, what did you put for the last one there? Yeah, it's the reflexive property. Anytime something is equal to itself, that's called the reflexive property. All right, guys, that's it for our lesson today. So go ahead and pack it up. We'll see you next time.